This is an experiment comparing the results of two actively aerated compost tea brewers. It arose from an analysis of an actively aerated compost tea which was brewed with the Bounty brewer. The sample was brewed by one of our master gardeners and then stored in the refrigerator for a couple of days until it could be given to me for analysis. The results were troubling. As detailed in the video IVC LB CT 2012-09-19, the sample was anaerobic, measuring dissolved oxygen at 4.5 milligrams per liter. We were wondering whether the Bounty brewer might be brewing an anaerobic tea. Even though the Bounty brewer does have an air stone which bubbles oxygen into the brew, some researchers believe that air stones themselves harbor sufficient pockets of anaerobic bacteria to cause a brew to go anaerobic, especially during the later stages of a brew, when the growth rate of the aerobic bacteria can easily exceed the capacity of an aerator to provide sufficient oxygen. We decided to construct an experiment using two actively aerated compost tea brewers which use very different aeration strategies. As I said, the Bounty brewer uses an air stone. The Sweet Soil brewer uses a single pipe to provide aeration. Here you can see the Sweet Soil brewer blowing air into a bucket of water through a single 5/8 inch internal diameter pipe, and then the Bounty brewer blowing air through an air stone. We based our brews on the same compost starter that had been used in the original anaerobic brew. I mixed 2 bags of humus soil together and then divided this mixture between the 2 brewers. Here are the 2 brewers. I've washed them out and now I'm filling them with water. You can see. Trying to keep them the same. Here they are. These 2 brewers use very different strategies. It's kind of bit hard. Aeration, or at least turbulence, in the Sweet Soil brewer, which is based on the late English design. And you can see that the Bounty brewer has a much more fish tank-like set of bubbles coming out of the air stone. The Bounty brewer has a different configuration. The air stone sits down inside this bag that kind of hangs over the edge of the bucket. And in the Sweet Soil, the Ingham design, the blower is actually mounted into the lid. I don't have it here connected up here, and the bag hangs down from the lid into the bucket. I didn't bother running the brewers with just water in them, as the Bounty recommends running for an hour to basically get the chlorine out. It turns out that we have chloramine water here in California, and that won't work. So there's really no point. And besides, just because I'm doing a side-by-side, we're just going to compare the performance of these 2 brewers. So I don't really care about that. It won't help anyway, because the chloramine won't get aerated off. Here's what the 2 brewers look like set up. This is the Bounty brewer with the material, the compost, which is Bounty humus soil. What I did was I mixed them in a bucket. I mixed the 2 packets in a bucket and then split them up so that we wouldn't have any differences between the 2 packets. Even though under the microscope they look pretty similar. So that's in the Bounty system, the bag hangs over the edge and the material is inside. And in the Sweet Soil Ingham system, the bag hangs into the lid through this basically this retaining ring. So let's crank them up. Here's the Bounty brewer, and here's the Ingham brewer. You can't really see inside, but if I lift the lid, slightly different strategy. So we'll see how they do. Here is what the Bounty brew looks like at the beginning, hour 0 of our test. I found a moderate number of healthy fungal hyphae greater than 2 microns, no nematodes, fairly low bacteria counts and activity, and very few protozoans, just a few testate amoeba. And here is what the sweet soil brew looks like at hour 0. Again, moderate fungal hypha greater than 2 microns, no nematodes, low bacteria counts and activity, and just a few testate amoeba. At hour 6, the Bounty brew had better bacterial activity, but the fungal hypha seemed to be disappearing. I did not find any nematodes, and just a few testate amoeba. Here is the sweet soil brew at hour 6. Bacteria counts were increasing. There seemed to be some very active motile rod bacteria, and even a few flagellate protozoans in addition to a few testate amoeba. I didn't see any nematodes. There seemed to be more fungal hypha present than in the Bounty brew, but I have noticed that in general, getting fungal hypha to grow in a compost tea seems to take specialized skill. At 22 hours, the Bounty brew had good bacterial activity. There were even what looked like flagellates, but this might have been very fast rod bacteria. I saw a few fungal hypha greater than 2 microns. I did not see any nematodes. Here is the sweet soil brew at 22 hours. I did not see any fungal hypha greater than 2 microns. There was good bacterial activity, and like the Bounty brew, some flagellates, which are probably very fast rod bacteria. It was hard to tell. I did not see any nematodes. At 27 hours, the Bounty brew had good active bacteria and some cilia, but no nematodes or fungal hypha. At 27 hours, the sweet soil brew also had good active bacteria. I saw a few fungal hypha greater than 2 microns, but no nematodes or protozoans. My last look at the Bounty actively aerated compost tea brew was at hour 34. I saw lots of active bacteria, what looked to me like more rods than cocky. I saw one fungal hypha greater than 2 microns, but no protozoans. At 34 hours, the sweet soil brew looks similar. A few fungal hypha greater than 2 microns, one testate amoeba, no flagellates or cilia or nematodes. In all cases, for all 34 hours, the sweet soil brewer made a darker brew. This is the final one after 34 hours, but they're all typically about the same ratio. Here is a graph showing the dissolved oxygen measurements for the duration of this experiment. Tap water was my control. It is interesting to me that the Bounty brew had consistently higher dissolved oxygen right until near the end, when the sweet soil brew passed it. Clearly, the Bounty brewer should not be run for more than 24 hours to achieve optimal results. This graph shows the temperature measurements for the duration of the experiment. In this case, it appears that the sweet soil brew maintained a consistently higher temperature, which I presume means that it was generating more microbiological activity. In this final set of scenes, we are looking at a sample of each brew which was taken after 27 hours, but sat around in a container until 34 hours. I wanted to see if there was an evolving difference between the two brews if they were not given any further oxygen. These samples are actually the two samples I used in the color comparison scene. It seemed to me that the Bounty brew was favoring rod bacteria. The sweet soil brew to me looked about the same as it had at hour 27.